So now they're giving us some information. They're saying that side A is equal to 4, so that's going to be opposite angle A, so that's 4. They're giving me the angle of angle A is 60 degrees. They want me to find the two missing sides and the missing angle. Remember, uppercase letters will always represent angles. Lowercase letters will always represent sides. So you can see that this is going to be a 30, 60, 90 triangle. So angle B I know is 30 degrees. So they're giving me the side opposite my 60-degree angle. So in the relationship, remember the hypotenuse is 2x. The side opposite my 30 is x. The side opposite 60 is always equal to x times square root 3. So then to find my shortest side, what I'm going to do is I'm going to have to take 4, set it equal to x times square root 3. Divide by square root 3, so 4 over square root 3 is equal to x. Rationalize the denominator, multiply numerator and denominator by square root 3, so I end up with 4 square root 3 over 3. So then what I do know is I know that the side opposite the 30-degree angle, which is going to be side B, because it's opposite angle B, is going to be 4 square root 3 over 3. So then my hypotenuse is going to be 2 times this. So 2 over 1 times 4 square root 3 over 3 is 8 square root 3 over 3. Now, if you also remember back from geometry, you did that SOHCAHTOA. You just looked at some trig ratios. So if you remember, you are still dealing with a right triangle, but we don't know the other two angles. So your trig ratios can be set up. Remember, your SO stands for the opposite over hypotenuse. The CA is the adjacent over the hypotenuse. The OA for TOA is the opposite over adjacent. So when you look at a trig ratio, they always have to give you some angle. Now, in algebra, we always use variables x and y, it seems a lot. In trig, and as we study angles, and that's what trig is, a lot of study of angles, the variable that we use to represent an angle is what's called theta. It's the variable that we use, so when you see theta, you know it's a variable that's going to represent some angle. It's an angle measurement. So just like an x and a y in algebra, when we're dealing with angles, we use a lot of this symbol theta. So that's what you see right here. So the sine of theta, you would want to think of this as your reference point in the triangle, because you always have to know when you're setting up your trig ratios, what's the reference point. So if I want to set up the sine of theta, in terms of my reference angle, or reference point, I want to find the side opposite this particular angle theta, which is side B, over the hypotenuse. The hypotenuse, remember, is always opposite the right angle. So that's going to be B over A. Cosine is that angle that's left over. That's what we call the adjacent angle. So that is your side C over the hypotenuse, which is A. TOA is the opposite over adjacent, so that's going to be B over C. Now, there is actually 3 other trig functions that you haven't studied yet that we're going to look at this particular semester when we talk about our trig. That is the first one being a reciprocal function for sine. And the reciprocal function for sine is your cosecant, or we abbreviate as CSC. So since you know that sine is opposite, remember what reciprocal means is you switch the numerator and the denominator. So for cosecant, it's going to be the hypotenuse over the opposite. The reciprocal function for cosine is the secant, or we abbreviate it as SEC. So since cosine is adjacent over hypotenuse, the secant is going to be hypotenuse over adjacent. The reciprocal function for tangent is cotangent, and we can abbreviate that as COT. And again, since we know tangent is opposite over adjacent, then we know cotangent is going to be the adjacent over the opposite. So just some reciprocal identities that we're going to look at this particular year. Sine is going to be equal to 1 over its reciprocal, which is cosecant theta. Cosecant is equal to 1 over sine theta. Cosine is equal to 1 over secant theta. Secant is equal to 1 over cosecant theta. Tangent is equal to 1 over its reciprocal, cotangent theta. Cotangent is equal to 1 over tangent of theta. So if you remember, when you're dealing with right triangles that are not part of your special right triangles, as long as you know 2 of the 3 sides, then you can use your Pythagorean theorem to find the third side. So a squared plus b squared equals c squared. And remember, c is your hypotenuse. So if it's a 30, 60, 90, or 45, 45, 90 triangle, as long as you know one of the sides, you can find the other 2 sides. Otherwise, you have to know 2 sides of the triangle in order to use Pythagorean theorem. So that's your Pythagorean theorem if you remember back from your geometry. So when you want to find the 6 ratios, the 6 trig ratios, you always start with the SOHCAHTOA. Because you find sine, cosine, tangent, you can find the other reciprocal ones pretty easily. So remember, this is my reference angle in my triangle. So the opposite side is going to be opposite that reference point, which is 5. So this is my opposite. The hypotenuse is always opposite the right angle. So this is the hypotenuse. The third and remaining side is your adjacent side. So sine is going to be the opposite, which is 5, over the hypotenuse. Well, if you know sine, you know it's reciprocal cosecant because you're just going to take the reciprocal, so that's going to be 13 over 5. Cosine is the adjacent over hypotenuse, so that's going to be 12 over 13, or 13 over 12. Tangent is the opposite over adjacent, so that's going to be 5/12. And if you do tangent, you know cotangent, which is 12/5. So that's how you would find your trig ratios. So find the 6 trig ratios for angle A. So angle A is my reference angle right here. If side A is 3, so remember that's going to be opposite angle A, and side C is 9, which is going to be opposite angle C. The problem is I do not know the hypotenuse, but I do know 2 of the 3 sides. So first of all, to find side B, I'm going to have to use my Pythagorean theorem. So 9 squared plus 3 squared equals b squared. So 81 plus 9 is equal to b squared. So 90 is equal to b squared, so I have to take the square root. So I can simplify the square root of 90 into the square root of 9 times square root of 10, and that's going to give me 3 square root 10. So remember, before you set up set up trig ratios, you first have to make sure you know all 3 sides. So since angle A is the reference point in the triangle, I know that side A is my opposite side. The hypotenuse is the side opposite my right angle. The adjacent side is the third remaining side. So now I can set up my SOHCAHTOA. So the sine, now when you write a trig function, you always put the angle reference after the trig function. So sine of A is going to be the opposite over hypotenuse. So that's 3 over 3 square root 10. Always simplify your fractions. So I can simplify this to 1 over square root 10. And when I rationalize the denominator by multiplying the numerator and denominator by square root of 10 over square root of 10, that's just going to give me square root of 10 over 10. Now with its reciprocal function cosecant, remember when I simplified the fraction before I rationalized, I ended up with 1 over square root 10. Don't make extra work for yourself. I'm going to flip this fraction 1 over square root 10, which is just going to give me square root 10 over 1. If you love rationalizing denominators, you could have certainly flipped that one right there, and then you just have to rationalize the denominator. Cosine is the adjacent over the hypotenuse. So that's 9 over 3 square root 10. There is a common factor I can divide out of 9 and 3, which is 3. So that's 3 over square root 10. Again, I'm going to rationalize that denominator. That's going to give me square root 10 over square root 10. So that gives me 3 square root 10 over 10. Its reciprocal function secant, again, just like I did with sine, flip the fraction before you rationalize the denominator to save yourself some work. So 3 over square root 10 will be square root 10 over 3. And then finally, tangent is going to be the opposite over adjacent, which is 3 over 9, which simplifies to 1/3. Cotangent is going to give me 9 over 3, which is just 3. So there are my 6 trig ratios when I had to find a side of the triangle using the Pythagorean theorem. Okay. So now notice in my next case, I'm giving you some 30, 60, 90 triangles, but these all have a hypotenuse of 1. So again, remember, this is a 30, 60, 90 triangle. Remember the relationship of my triangle. The 30 is what I'm calling x. The side opposite my 60 is x square root 3. The hypotenuse is 2x. So to find my shortest side, I'm going to take the hypotenuse here, giving me that 1 is equal to 2x. X is equal to 1/2. So in this 30, 60, 90 triangle, the hypotenuse of 1, the side opposite 30 is 1/2. I'll take 1/2 and multiply it by square root 3. So I can write this as square root 3 over 2. So there are the 2 missing sides of that particular right triangle. 45 degrees. Notice the hypotenuse is 1. So in my 45, 45, 90, I know these 2 legs are congruent. And the relationship of the hypotenuse is going to be x times square root 2. So 1 is equal to x square root 2. Divide by square root 2, so 1 over square root 2 is equal to x. So then x is going to be equal to square root 2 over 2 when I rationalize. Okay. So I've already done a 30, 60, 90. Remember, I just put the 60 degree, I just flipped where the 30 and 60 degree angle was. So I know the hypotenuse is 1. Remember the side opposite my 60 degree angle, I found to be square root 3 over 2. And the shortest side is 1/2.